Let's start with our first problem. So our first problem says the acceleration of an electron due to the mutual attraction between electron and proton when they are separated by 1.6 angstrom apart, okay, is, so we have to find the mutual attraction. Mutual attraction or repulsion means basically the force we have to find in this case, where we have one electron and proton and both are separated by 1.6 angstrom. So let me first write here electronic charge. One electronic charge is nothing but minus 1.6 into 10 raised to minus 19 coulombs, okay, and the charge of one proton will be equals to same 1.6 into 10 raised to minus 19 coulombs. And here the separation R is nothing but 1.6 angstrom. Angstrom is nothing but 10 to the power minus 10, okay. So this is our charges and separation. What we have to find? We have to find the force. So our force formula, okay, Coulomb's force is nothing but F is equals to K Q1 Q2 upon R square, okay. Be very careful, this is a magnitude over here, so we don't take the negative sign here, okay. So this will be simply, what is K? Let's substitute the values. K is nothing but 9 into 10 to the power 9. Charge Q1 is the charge of electron. The electronic charge is 1.6 into 10 raised to minus 19 over here, and into 1.6 into 10 raised to minus 19 for the proton, whole divided by the separation, which is 1.6 into 10 raised to minus 10 into 1.6 into 10 raised to minus 10, okay, because it's a square in the denominator, okay. So this is our force. Let's calculate it. So let me cancel the terms which are getting cancelled here. So this will be here 1.6 and 1.6, they will cancel out all of them. So let me cancel this 1.6 with 1.6 here, and we left with, let's see, 9 into 10 to the power 9, and in the powers 10 to the power minus 38 in the numerator, and denominator it is 10 to the power minus 20. Great, let's move ahead, okay. And here, which is equals to, let me take here, so which is equals to 9 into 10 to the power 9 and 10 to the power minus 38 and 10 to the power minus 20, that will become how much? 10 to the power minus 18, okay, 10 to the power minus 18 here we left with. So our result will be 9 into 10 to the power minus 9. Our result will be 9 into 10 to the power minus 9, and that's what force. So newtons. Let's read the question again. The question says the acceleration of the electron. We have to find the acceleration. So what we have calculated just now, we have calculated the force, right? So what is force by Newton's second law? By Newton's second law, let me write here Newton's second law from 11th standard. Newton's second law says force is nothing but mass times acceleration of the object, correct? So how much force we calculated here? Let me first figure out the acceleration. That will be in terms of force by mass, and that is 9 into 10 to the power minus 9 divided by the mass. How much is the mass over here? As per the question, if I scroll up, the question says mass of the electron is 9 into 10 to the power minus 31. So let's substitute here 9 into 10 to the power minus 31, okay, that's the mass of the electron over here. So this will be equals to 10 to the power minus 9 into 10 to the power plus 31, and 31 minus 9, that will give you nothing but 10 to the power 22. And what's the unit of acceleration? Meter per second square. Let's see if we have such an answer. So yes, option C is correct for question number 1, okay. So this is question number 1. This is previous year's NEET question, okay. So this was, okay, previous year's NEET question, question number 1. Let's move to question number 2, okay. So question number 2. Question number 2 says 2 point charges A and B. There are two charges A and B, okay. Let's draw a rough diagram over here. So let me take this is as our A and this as our B. Having charges Q and minus Q. So let me just write here plus Q, and let's keep here minus Q, okay. Q and minus Q respectively are placed at a certain distance apart, and a force acting between them is F. So let's say this separation between them is X or R. You can take anything. Let's take it as R, the separation between A and B, and the force acting between them as per the question is F. This is the force, correct? if 25% of the charge, okay, of A is transferred to B. Let me repeat again, if 25% of charge of A is transferred to B, then force between the charges becomes how much? Clear? Very simple question. So let's initially write what will be the initial force. So initial force F will be equals to K times charge on A times charge on B. Let me remind you again, we don't take the negative sign because of magnitude, whole divided by R square. Correct? So let me rewrite it as our initial force when the charge was not transferred, it was KQ by R square. This is our equation number 1. Okay, where K is nothing but 1 by 4 pi epsilon naught if you want to write. Okay, now 25% of charge A of, let me write here, 25% charge of A is transferred to B. Okay, 25% of A. Then what will be the charge left in A? Obviously 75%, because total is 100 always, right? So what is the charge, new charge on A? So Q dash A, that will become how much? 75% of this charge on A, correct? And that is nothing but how much? QA. QA is Q, right? So 75 upon 100, let's cancel out, it will be 3 by 4. If you divide by 25, 25 3s are, 25 4s are, right? So into Q, correct? Because charge of A is Q. This is our charge on A, new charge on A after the transfer. What is the new charge on B? The new charge on B will be QB, and that will be how much? 25% of A, which is given to B, as well as the charge which was already there on B, correct? Let me repeat again, if 25% is charge is given from A to B, so this is 25% of A plus the B charge, right? Because QB was already there. So what is the charge? 25 by 100, 1 by 4 of QA, which is plus Q. And be careful, charge is a scalar quantity, you can add or subtract, so you have to keep the negative sign, minus Q. Force is a vector quantity, right? So be very careful with that. And charge is a scalar quantity. So for force, vector addition, charge is direct scalar addition. So this will be minus 3Q by 4. This will be the new charge on B. I hope this is clear. So this is A, this is B, new charges. Let's find the new force. So the new force will be F dash, and that will be equals to K, still remains K, nothing changes to the medium. Now what is new charge? QA dash into QB dash whole divided by R square. Nothing, the question is saying nothing about the separation between the two charges, right? So R will still remain R. Okay, so let's substitute the new values of charges of A and B. So QA will be nothing but 3 by 4 of Q. Let's keep a bracket to avoid mistakes. And into, this is minus 3Q by 4, that's charge on B, whole divided by R square. So let's simplify it. 3 3s are 9, so it will be minus 9 upon 16 KQ by Q square by R square, correct? And what is KQ square by R square from equation 1 over here? The equation 1 says this is nothing but force. F prime will be equals to minus 9 by 16 F, correct? So we can ignore the negative sign. This is simply the magnitude they are asking. So magnitude of the new force becomes how much? 9 by 16. So that is option A. The correct answer is option A. 9 by 16 of F. Clear it is? This was our question number 2. Okay, great. Let's move to question number 3. So question number 3 says 2 point charges plus 9 microcoulomb and Q2 is minus 1 microcoulomb are held 10 centimeter apart. So our Q1 is how much? 9 microcoulomb. Let's keep it here. Let's make a diagram over here. So this is our A, this is our B, this is our plus 9 microcoulombs, and this is minus 1 microcoulombs. They are separated by a distance of 10 centimeter apart. So let me draw here in between. This is our 10 centimeter, or let me just keep it as 10 into 10 to the power minus 2 to avoid mistakes. Okay, where should a third charge plus Q be placed from Q2? From Q2, Q2 means the second charge from Q2 on the line joining them, so that capital Q does not experience any force. So we are placing a third charge, okay, along the line joining these two set of charges, but near B. Be very careful, we are placing it near B. Okay. So what we can do, let me repeat the whole question. Let's understand the problem in a simple way. You are given with two charges, 9 microcoulomb minus 1 microcoulomb. Both are separated by a distance of 10 centimeter. You have to place a third charge, capital Q, okay, on the line joining the two charges such that the net force on this Q will be 0. Equilibrium, net force is 0, right? Okay. Let's see now the situation. Now, they said you have to place it close to B. So you have two options, either on the left hand side of B or on the right hand side of B, correct? These are the two only options. So basically, let's see what happens if I take it on the left hand side. So if you find the directions due to this plus 9, the force, okay, if you find, okay, that will be attractive or repulsive, that will be, this will be at this point, okay, it will be going towards it. And even the negative charge, okay, that is very, very small. So it is going towards the positive charge. So this is not a good idea because the field will not cancel out here. The field will add up. Let me repeat again. If you take here the electric field direction for positive also outward, negative also inward. So add up. While the field will cancel out on the right hand side of B, because the field due to positive will be outward and due to the negative it will be inward. So there is an angle of 180 degree. So the good choice will be placing it on the right hand side of B. So let's take this, assume this as x, this point P as x distance away from charge B on the right hand side of B. Great. Net force is 0. Now let's figure out the force. Okay. Okay. So let's place it here, our Q, a new charge. So what is the force on Q due to the first charge? So that will be F1, that will be equals to K, 1 by 4 pi epsilon naught, which is K. Q is how much? 9 microcoulomb. So 9 into 10 to the power minus 6 into capital Q upon what's the separation? Sir, from A to B it is 10 centimeter. Then B to P, x. So total distance will be 10 plus x, okay, centimeter. So let me write here, keep a bracket and let me just make it 10 to the power minus 2 whole square. Let me repeat again, 10 centimeter. 10 centimeter means 10 into 10 to the power minus 2, and I assumed that it is also in x centimeter only, right? So 10 plus x into 10 to the power minus 2, 10 to the power minus 2 because both are in centimeters. Force F1. Let's figure out the force F2. So F2, force on charge Q due to charge at B, that will be again 1 by 4 pi epsilon naught. And this will be what? Our directions will be opposite. We know that, okay? So this will be again how much? 1. So it will be Q into 1 into 10 to the power minus 6 whole divided by separation x into 10 to the power minus 2 whole square. Correct? I hope this is clear. These are the two. We have not taken the negative sign. Be very careful. Okay. We will take it. We will consider here the net force is 0, which means they are cancelling out. So F1 minus F2 is equals to 0 as per the question. The forces will become 0 only if they are acting upon in the opposite direction, right? So F1 will be equals to F2. Now what is our F1? F1 is 1 by 4 pi epsilon naught into Q into 9 into 10 to the power minus 6 whole divided by, this will be, let's make it as 10 plus x whole square, and that 10 to the power minus 2, this one, okay, what we will do? We will take it out of the bracket and make it as 10 to the power minus 4 because we have to cancel it, okay? And that will be equals to F2. What is F2? 1 by 4 pi epsilon naught. Q will remain Q and the charge will be 1 into 10 to the power minus 6 whole divided by how much? This will be x into 10 to the power minus 2 whole square. So x into 10 to the power minus 2 whole square, what I am doing? I am taking it out again into 10 to the power minus 4. Let's cancel out the terms. Okay, the like terms or alike terms. Q is cancelling on both the sides. 10 to the power minus 6 cancels both sides. 10 to the power minus 4 cancels both sides. 1 by 4 pi epsilon naught cancel out both the sides. Let's take it, okay, this bracket on the right hand side. So 9 is equals to 10 plus x whole square upon x square. So this will give us taking the square root both the sides. Clear? So this will give us 3 is equals to 10 plus x upon x. So 3x is equals to 10 plus x. So x is equals to 2x is equals to 10, or x is equals to 5 centimeter. Be very careful. We took it in terms of centimeter. So let me check if there is any option. Yes, option C is the correct answer. 5 centimeter for question number 3. Clear? Let's move to question number 4 here. Question number 4 says two charges each is equal to -4, okay, coulombs or microcoulombs are held at a certain distance apart. A charge q is placed exactly at the midway between them. The magnitude and the sign of this capital Q, so that the three charges remains in equilibrium. We have to find it. Clear? So let's make a rough diagram. So first diagram over here is, let me just make it and let me decrease here this thing. Okay. So here let's say this is our A and let's say this is our B. Correct? And this is the line joining the two charges. Correct? And here this is our O. This is our separation R between A and B. So this gap will be nothing but R by 2. Correct? So charge Q1 will be -4 microcoulomb as per the question, and this will be also 4 microcoulomb as per the question. Right? This is our center Q. I hope this is clear. Right? Now what you have to do? You have to find the magnitude of this capital Q so that the whole system remains in equilibrium. Right? The system will remain equilibrium if the net forces, okay, they will cancel out, right? Just now we have seen in the previous question, if they are cancelling out, net force is 0, and net force is 0 means they are in equilibrium. So simple concept, right? So what we will do here is, we will first find the force between the first charge A and O and the force between A and B. Clear? Let me repeat again. The force we will find, because previously when this Q was not there, they were having some repulsive force between them, right? A and B were having some repulsive force between them. Due to the presence of this Q, they are affecting this repulsive force. So we will find, because both are equal charges, right? So first we will find force due to A or B, let it be, because both are same, right? So force on this O, let's find it. That will be equals to how much? Okay, that will be equals to K, which is 1 by 4 pi epsilon naught. Q is first one, this. Second charge is 4 into 10 to the power minus 6. Again I am repeating, negative sign is not considered, but resultant is 0, which means net will give you 0. So you will subtract them at the end, right? So this is the force, whole divided by separation R by 2. Yeah. No matter if you consider A or B, both have same, and separation also R by 2, right? Okay. Clear it is, I hope. So this is R by 2 whole square, K Q1 Q2 by R square. Okay. Now let's find the force, repulsive force acting between A and B. So repulsive force between A and B will be equals to 1 by 4 pi epsilon naught. First charge is 4 into 10 to the power minus 6. Second charge is 4 into 10 to the power minus 6 whole divided by separation. Now separation is R square. Correct? Okay. Now this force is resulting in 0, which means F naught minus F is equals to 0. It has to be 0, then only they are in equilibrium, right? So let's substitute, or before substituting, let's take on the other side like we did in the previous problem, so that things will cancel out. So let me substitute here F naught, which is 1 by 4 pi epsilon naught Q into 4 into 10 to the power minus 6 whole divided by R by 2 whole square, and that is equals to 1 by 4 pi epsilon naught 4 into 10 to the power minus 6 into 4 into 10 to the power minus 6 whole divided by R square. Let's cancel out what are the things which are getting cancelled. Correct? So here this thing will cancel out. Our 4 pi epsilon naught is getting cancelled, and 4 into 10 to the power minus 6, one of them cancels out. We left with here on the left hand side Q upon R square by 4. R square by 4. So let's take that 4 on the top. You can keep it below, your wish. Okay, but it will eventually go on the top, and that is equals to 4 into 10 to the power minus 6 whole divided by R square. Let's cancel out r square both the sides. So cancelling r square both the sides, Q will be equals to 4 upon 4, 1 into 10 to the power minus 6 coulombs. Clear? So this is our charge. If you go back, the question says what will be the magnitude and the sign. See here both the charges are negative. So to keep them in equilibrium, this must be positive. So correct answer is option A, positive 1 microcoulomb. I hope this is clear. Okay, this was question number 4. Let's move to question number 5. Okay, so question number 5 says, suppose the charge of a proton and an electron differ slightly. Okay, let's say this is a hypothetical situation that maybe the charge of a proton and electron inside the atom differ slightly. One of them is negative E and the other one is E plus E. Okay, this is the condition. One is negative, one is E plus E. So delta E jo hai, that is your slightly change. If the net of electrostatic force and gravitational force between the two hydrogen atom placed at a distance of d much greater than the atomic size apart is 0, then delta E is of the order what? Okay, let me explain you first question, then we'll go for the solution. So question says that the charge on a proton and electron is differing slightly, and if you take two hydrogen atoms, what is the hydrogen atom? The first element in the first element of the periodic table, and it has one electron in the outermost shell. Okay, and nuclei contains one. Now I am not assuming isotopes here, right? So I am assuming one proton is there, single proton, and around which the electrons are revolving, right? Now in that case, if the charge is differing by a slight value, what will be the ratio of gravitational to electrostatic force, provided they have given that this is 0. Okay, you can see here, so this apart is 0, we can see. Okay, so let's start with question, and as I will solve, you will understand it better. So first thing, if there is a slight change in the charge of an electron and a proton, clear? So if there is a slight change, then what is the new charge? New, previously what? Okay, let's take the previous case. In the previous case, when there is no change, we know that hydrogen atom, there is a nuclei in which there is a proton and an electron is revolving around. So what is the overall charge of an atom? 0. Because we know that charge of a proton is positive 1.6 into 10 raised to minus 19 and electron is negative 1.6 into 10 raised to minus 19. So atom as a whole, all the atoms are neutral as a whole because the number of electrons are equal to number of protons, right? Coming back to this, now the problem is saying that we have a differing charge. So in that case, the new charge of this hydrogen atom we have to calculate. So new charge on one hydrogen atom, that will be how much? Q, and that Q will be equals to minus E, that will be the new charge on electron, plus the protonic charge which is differing by delta E, right? Previously this delta E was not there, so that's why it was neutral, but because of this delta E, the new charge will be delta E. This is the overall charge of a new hydrogen atom, right? So what will be the repulsive force acting between two hydrogen atoms? So let's imagine the scenario. This is our hydrogen atom, new hydrogen atom with delta E overall charge, another hydrogen atom with new delta E charge. What will be? They will attract or repel? They will repel. Why? Because the charges are of same polarity, right? So force of repulsion Fr will be equals to K Q square. Q square is delta E. I am not putting the value of K. Maybe at the end we will cancel out. Okay, whole divided by the separation. So let's call this separation as D. Okay, because they have not mentioned the separation. Okay, now they are saying they have mentioned if the net of electrostatic force and gravitational force between the two hydrogen atom placed at a distance d, right? So both have a separation, same separation, right, for gravitational as well as electrostatic. So let me just keep it as equation 1. Okay, great. Let's move ahead. And what will be our gravitational force between the two? So let me remind you from class 11. Gravitational force is G, M1, M2. Both will have same mass, right? Nothing. You are not changing the configuration. Hydrogen atoms are there. Only you are changing the charges, right? So mass M square upon the separation square D square. Correct. This is our equation 2. Given here mass of hydrogen atom is 1.6 into 10 raised to minus 27 kg in the problem, so we will make use of this at the end, right? So here, if the resultant is 0, we can say that Fr, both are equal and opposite, so this will be Fr equal to Fg, and Fr is nothing but R, you can take repulsive force, okay? So don't get confused, you can write electric force also, Fe doesn't make any difference, okay? That is just a notation. So this will be K delta E whole square upon D square, and the gravitational force is G m square upon D square. Now is there anything which is cancelling out? Yes, of course, D is cancelling out. Rest are constants. Let's plug in the values. So delta E is the charge whole square equals to G. Let me remind you, this is from 11th standard, 6.67 into 10 raised to minus 11 into mass square. Mass is just now given in the problem, that is 1.67 into 10 raised to minus 27 kg whole square, whole divided by K. K is 9 into 10 to the power 9, correct? Okay, we can further simplify it. So this will be our 6.67 into 10 raised to minus 11 into let me multiply 1.67 into 1.67, that will give me 2.7889 into 10 to the power minus 54 whole divided by 9 into 10 to the power 9. Great. So let me first simplify the magnitudes. So 6.67 into 2.7889 divided by 9, that will give you nearly 2.0668 into let me simplify 10 to the power 11 and 54, that will be how much? 65 minus 9, that will be minus 56. So 10 to the power minus 56, that will be your delta E square. Let's simplify it further. So here if we take the root of 2.0668, that will give us nearly 1.437, okay, and into 10 to the power minus 56, that will give you how much? Divided by 2, that's nearly 10 to the power minus 28. Let me just reconfirm these values. So here 6.67 and that is 27, okay? So 27 into 2 is equals to 54, minus 54 and minus 11, that will give you, okay, minus 54 and minus 11, that will give you minus 65, and minus 65 and 9, that will give you minus 56. So correct answer is 10 to the power nearly minus 28, correct? So nearly 10 to the power minus 28, that is our delta E, okay? So here there is slight variation. I have, let me just, because the 4 options are not same, so let me just check if I have gone through a mistake somewhere. 6.67 into 1.67 into 1.67 whole divided by 9. So this is 2.066 and this will be minus 54, that is correct. So there is a slight typing mistake, it is 10 to the power minus 28. So correct answer must be 10 to the power minus 28, because if you take the root of this 56, okay, that will give us minus 28. That's our correct answer. So correct option is option, let's make it B, okay, let's make it is 10 to the power minus 28. So this is the power, okay, magnitude wise you can keep it 1.437, but they are asking in order. If you read the question carefully, they are asking what will be the order of this delta E, okay? Delta E is of the order of 10 to the power minus 28, correct? This was our 5th question. Okay, let's start with question number 6. Question number 6 says, two identical charged spheres suspended from a common point by two massless strings of length L are initially at a distance d apart. So let me just make a diagram so that this becomes quite clear to us. So let me just draw a diagram. This is our, let's say, rigid support, and from this support there are two strings attached with which there are two spheres like this, correct? Now these are two charged spheres, okay, there are charges are residing on them, and the separation between them is d. So let's take a separation between them, okay, this is our separation between them, that is d, okay, great. Now they are saying the charge begin to the charge begin to leak from both the spheres at a constant rate. So both of them are leaking the charges, means charges are going away from these two spheres. Okay. As a result, the spheres approach each other. Obvious it is. Why they will approach each other? Because initially they are repelling each other because the charges are equal. Now when the charges are leaking, the charges on both the spheres A and B is decreasing. If the charge is decreasing, they will do what? They will attract each other. Why they will attract? Because the charge becomes lesser and lesser, stronger, repulsive force will become lesser and lesser. So it becomes weaker, right? Now what happens? Question is asking, as a result, the sphere approaches to each other with velocity v. Obvious it is, they will move. So where there is a motion, where there is a change in distance or displacement, there will be velocity, right? Then v varies as a function of the distance x between the sphere as. So we have to find the relation between. Okay. Let me repeat the whole question so that you can understand it better. We have two spheres, they are completely charged, A and B, similar charges, right? Why similar charges? Because they are repelling each other, right? And the question itself is saying two identically charged. Identically means same charges. Let's call this charge as Q over here and Q over here. Okay, great. Now they are suspended from a common point. Let's say this is the common point over here. Okay, great. With the two massless strings, okay, that is length L. So let's say this is length L. Sir, why massless? Because if the strings will have mass, you will have to consider the mass of the string as well, right? Great. Next is, are initially at a distance d apart. Now charges started leaking from both A and B, so they will slowly come closer. So let's say they come closer like this at some certain point, they reaches here. Okay. So when they are coming towards each other, their distance between them decreases and eventually velocity will vary. Okay. Let's start figuring out. Okay. So before we find this, let's find what are the forces acting on both of them. So let's consider the A. On A, there is a repulsive force due to B in this direction. Similarly, B is repelled in this direction. Correct? Repulsive force is always along the line joining the two, right? What is the force acting on A due to the gravity? That is the weight. So that will be mg over here. Correct? Weight is downward. So if weight is downward, mg is downward and Fe is there, let's find the resultant. So we know that the resultant due to both of them will be somewhere here, correct? If two vectors are acting like this, the resultant will be in this direction, right? Okay. Let's join them and let's imagine that from the center, okay, this is a line joining, so this will be d by 2 and this is theta. What is theta? Read the question carefully. D is very, very less than L. So theta is very small angle, okay? So that is d by 2. This is also d by 2. The separation whole thing is d. I hope this is clear. Now look at two triangles. Which two? Let me join this one. Okay. So let's just make this one as little small. Okay. So here it is. Let's make it like this. So look at this triangle over here and this triangle. In both the triangles, this is vertically opposite angles, correct? This is over here 90 and this is over here 90. Both are 90 degree. The third angle has to be equal, so this will be angle theta. I hope this is clear. Clear? So one is theta, okay, and okay, another one is 90 and third is vertically opposite angles. Let's take this triangle. Let me call this triangle A is already name given here. Let me call it as P and let me call it as Q. So let's take triangle APQ. In triangle APQ, what will be your tan theta? So tan theta is always perpendicular over base. So if you take a triangle like this, right angle triangle, and this is angle theta over here, then theta with the side is base and the opposite one is perpendicular, right? You can, if you remember it like opposite or adjacent, okay, you know that opposite upon adjacent is tan theta, right? So here the opposite is how much? That is our force Fe, and because this is our force Fe, AP is force Fe. So if you are confused, let me just write here first in terms of triangle sides AP vector upon our PQ vector, right? So AP vector is nothing but electric force Fe and PQ vector will be nothing but weight mg. So tan theta will be this. So what will be, let's write here in proper way, tan theta is nothing but electric force F upon mg. This is our equation number 1. Great. Okay, great. So if this is that, let's understand what is tan theta from another triangle. Let's call it as O and let's call it as X. Look at that from triangle AOX. What will be now tan theta? Tan theta will be equals to what? Perpendicular over this side, but this side whom will calculate? Let's calculate this side. Okay, that is L, that is d by 2. So tan theta will be equals to how much? That will be L d by 2, whole divided by root under L square minus d by 2 whole square. Let me repeat again. If I draw this triangle over here, which triangle, in case if you have not understood, that is XOA. Here is the angle theta, this is side L, this is d by 2. What will be this? Using Pythagoras theorem, L square minus d by 2 whole square. So perpendicular will be, or the opposite will be d by 2 here, and the base will be this, correct? So we will substitute here. So this will give you how much? D by 2 root under L square minus d by 2 whole square. Correct it is? This is tan theta. Okay. Now we can also use, since the angle theta is very, very small. Why it is small? D is very, very less than L. So in that case, small angle approximation says this is also equal to theta. Correct it is? So tan theta will be equals to nearly equal to theta. Or you can also write sin theta also you can take. Okay. Or instead of taking sin theta, we can take that L. If that theta is very, very small, this factor will be reduces to 0. Okay. Or you can take sin theta also and put it equal. That's your wish. So this second parameter will reduces to 0 and we will left with L square minus something will remain L square. So you will left with d by L. Clear? That is tan theta. Okay. Let's say this is our tan theta. So we will make use of this. This is our equation number 2. Okay. I hope this is clear. Let's say at any instant, listen very carefully, at any instant, these two sphere balls were somewhere here in between like this. Then this theta will be much smaller, right? Okay. In that situation, and instead of taking it as d, let's call it as x. The separation between them is x. So this will be our small angle approximation. We can make it as theta will be equals to x by 2l, because the distance, the separation between the two will be x. So this is our equation number 3. I hope this is clear. You can keep it tan theta also. Let's recall our equation 1. So let me write it here. From 1, tan theta is also nearly equal to theta. So that will be x by 2l will be equals to force. At that instant when they are x distance apart, what will be the force between the two spheres? K, which is 1 by 4 pi epsilon naught. Charges on both the spheres is how much? Q square upon kq square upon separation between them, that is how much? X square. And this mg is already there, so let's keep here mg as this. Correct? Let's cross multiply. It will be x cube, okay, and that will be equals to x cube upon 2l is equals to k q square upon mg. Now listen very carefully. K is constant, yeah, 1 by 4 pi epsilon naught, fixed value, doesn't change no matter if the charge is leaking or if they are coming close to each other. Mass of the sphere is changing? No, it's independent of charge. G value? No, we are on earth only, we are not going anywhere on any other planet. The length of the strings? No, the length of the string is still same only. It doesn't like you are taking 10-meter wire and tying a thread and later on it becomes 2 meter. No, so all other are constants. Only two things are proportional, which you can see from this equation, and that is x cube is proportional to q square, or q square is proportional to x cube, whatever you want to write. Clear? So we can now differentiate this equation. On differentiation, this will be what? Okay, but before we differentiate, let's find here. Okay, so we can say q is proportional to, let's square root both the sides, x to the power 3 by 2. Now let's differentiate. So differentiation will give you dq by dt and this is proportional to, what's the derivative here? The derivative of 3 by 2, that will be 3 by 2, which is a constant, x to the power 3 by 2 minus 1 half dx by dt, because we are differentiating with respect to t. Okay, so this is our implicit function. So 3 by 2 is a constant, okay, and dx by dt is what? V, correct? So we can say that dq by dt, let me write it here on this side, dq by dt is proportional to x to the power half into dx by dt is v. Clear? And if you take this x to the power half on the other side, v will be proportional to x to the power minus half. If you take it on the left hand side, x to the power half, it will be x to the power minus half, right? Okay, so this is the relation between v and x. They have not asked the relation between charge. Okay, so dq by dt is current. If they ask you the relation between velocity and the current, you can see that they are directly proportional, right? So here it is, v is proportional to x to the power minus half. So correct answer for this is option B. Again, previous year's question. Okay, so let's move to our question number 7. So question number 7 says so question number 7 says our 4-point charges, each equal to q equal to 4 microcoulombs, are held at a corners of a square. So let's draw a square over here. So this is our square, let's say. Okay, and corners of this square 4 microcoulomb. Let me place here 4 microcoulomb, 4 microcoulomb, and 4 microcoulomb, and 4 microcoulomb over here, and each side is 10 centimeter as per the question. Okay, find the magnitude and the sign of a charge, magnitude and the sign of the charge q, which is to be placed at the center of the square. Okay, you are placing a charge over here q, okay, center of the, okay, so that the system remains in equilibrium. So this is just an extended version of the previous type which we have done, where we had 2 charges and we used to place the third one, right? Okay, now here we are finding the force, okay, the resultant here. So you can choose, since you can see that all of them are 4 microcoulomb, right? So it's your wish if you want to find the resultant on A, B, C, D, doesn't make any difference, because all of them are there, they are influenced equally by this q. So what is the core concept here? The net force acting due to all other charges on A, let's say, let's start with A only, will be equal to the force acting between A and this O. Let me repeat again, the force acting between AB, AC, AD must be equal to the force of AO. If they are equal, then the resultant will be in equilibrium. Clear? So first of all, let's see what are the forces acting on A due to B. So that is a repulsive force acting in this direction. I am writing here force on A due to B. Force on A due to C, that will be acting in this direction, because this is the line joining the two. Force acting on A due to C, and force acting on A due to D, that will be in this direction, FAD. Now what's the angle between FAB and FAD? 90 degrees. So first of all, let me find the magnitudes of these, okay, so that we can use the resultant formula. So force on A due to B, that will be equals to K. Both charges are same, so I will put the values at the end. So K, Q1, Q2, Q square upon separation. Separation, all of them are similar, so separation is A square, okay, where A I am taking it as 10 centimeter. Similarly, what's the force on A due to D? K, separation same and charges are same, so A square. Two forces acting at what angle? Theta is 90 degree. So what will be the resultant? Resultant of these two. Which two? These two forces. We have not considered FAC yet, so be careful. So resultant of these two will be root under A square plus B square plus 2AB cos theta. This is from class 11th, okay, resultant of two forces. But here A is equal to B. So if A is equal to B, let me substitute A as FAB, and B is also FAB. Why FAB? Because FAB and FAD are same, right? We can see it on the screen. What is angle theta? So theta is 90 degree between FAB, which is here, this is one force, and another force is over here. So both are 90 degree apart. So what is cos 90? 0. So no need of writing the last term. Okay, so let me keep it up till here. Now this will give me what? This will give me, if both are same, so this will be FAD, instead of FAD, let me write it here, FAB only, same it is. So this will be root under 2 FAB, 1 apple plus 1 apple, 2 apples, and root and square will go, so it will be root 2 FAB. FAB is what? KQ square by A square. I hope this is clear. Now this is the force where it is acting. This is the force which will act along this direction. Okay, let me remind you from 11th standard, if one vector in this direction, another vector is in this direction, the resultant will be in this direction, right? So this will be our resultant, in this case R. Be very careful, this is not the net force acting on A, this is the force due to B and D. So this R is along AC. Can we add both of them? Yes. Directly? Yes, because theta is 0 degree between them, so you can directly add them. So net force acting on A, now we will get it, that will be R plus force due to C. R is how much? Root 2 KQ square by A square, and FAC. Now what's the separation between AC? AC square. AC is what? This gap is AC. So this gap is nothing but root 2 times A. So from where you got this relation? 10th standard. Okay, you can use diagonal, this ABC as a right angle triangle, use Pythagoras theorem, take it as A, take it as B, A, both are A, so that will be root 2A, right? Okay, great. So try this yourself, how to find the length of the side AC. So this will be force FAC, K, charge on A, Q, charge on C also Q, upon separation, root 2A whole square. So this will be, let's take common here, let me just scroll down and take common here. So this will be KQ square by A square, and here you left with root 2 plus 1 by 2, correct? This is the net force acting on A. Now the question, let's read the question. Okay, you can choose even B, C, anyone. Okay, so the question says, find the magnitude and the sign of the charge on Q, charge Q, which placed at the center of the square, so that the system of the charge is in equilibrium. Now these FA is the net force acting due to B, C and D. This must be equalized by the force acting between A and the center. What is A? A here is K, let me write here, Q, capital Q is the charge at the center, and what's the gap? If this is root 2A, what's the gap between A and O? Root 2A by 2. Look at the diagram. This is root 2A by 2. So let me keep it here, root 2A by 2 whole square. Let's simplify this to get the value of capital Q. So this will be our, here, K cancels with K, Q cancels with one of the Q, and this will be left with Q upon a 2A square by 4, and that is 1 by A square, 2 root 2 plus 1 by 2. Let's cancel this A square with A square, and taking 2 by 4, which is 1 by 2 on the other side, it will be Q equal to 1 by 2 root 2 into 2 plus 1 by 2. Clear? And this, on solving further, okay, will give us, let's see how much. So this will be 2 2s are 4. Okay, so it will be 2 root 2 plus 1 by 4. So this, okay, this will be our charge at the center. Okay, but there is one Q more left which I missed at this point. We cancelled only one with Q. So let's place it here again. A small Q is left, right? There is a Q square on the right hand side. So into 2 here, into Q here. So substituting the value of Q, what's our Q? Let's scroll up, and this is 4 microcoulombs. So let me place here, it will be 2 root 2 plus 1 upon 4 into 4 microcoulombs, that is 10 to the power minus 6, 4 cancels. So our final result is, what is the net charge? It will be Q equals to 2 root 2. All are positive charges? Yes. So what should be the magnitude of this, sorry, charge of this? Polarity negative. So minus 2 root 2 plus 1 microcoulomb. So that is option A in this case. Negative because to get in equilibrium, the central charge should be negative because all other are positive. If you remember the previous question, that was all were negative. So we had placed a positive sign. So problem 8 says, 2 pith balls carrying equal charges are suspended from common point by the strings of equal length. Okay, the equilibrium separation between them is R.
So here this is the equilibrium separation initially, okay, that is our R, okay. And secondly, now the strings are rigidly clamped at height h, okay. So our new height is h. The equilibrium separation between the balls now becomes, so this new h is simply y by 2, okay. So y by 2 is the new separation, previously it was y, and we have to find the new equilibrium separation between the two balls. Clear? So let's start first of all, like in previous problem number 6, okay. We saw that tan theta, so tan theta was nothing but it is equals to force, electric force Fe upon mg, where mg is the weight of this ball. Let me remind you once again, here this will be the repulsive force Fe, and here this will be the weight of this ball mg. And let's suppose here this is angle theta, okay. So if this is angle theta, then what we can do, this angle, if we make, this is theta, and if we make a triangle over here, okay, like this, then this vector will be mg over here, and that will be Fe. Then this angle will be 90 minus theta, because here it is 90, so that will be 90 minus theta. And if that is 90 minus theta, we can see that this will be 90 minus theta, and here it will be theta, okay. Now if that is theta, again you can find tan theta, and that will be your this is our equation number 1, okay. Now similarly, if they are at this position, which one? At this position here in the second case, then here it will be mg, and this time the force will be Fe prime, okay. If Fe dash, let's take it, okay. And now the tan theta will be, let's call it as tan theta 1 or tan theta dash, that will be equals to how much? Fe dash upon mg. This is our equation 2 in the second situation, right? Now what we will do? Now we will divide equation 1 and equation 2. So when you divide equation 1 and equation 2, tan theta upon tan theta dash, that will give you how much? Fe upon Fe dash. I hope this is clear. Clear? So let's go on the other side and write what is our tan theta, okay. Tan theta is what? Perpendicular upon base. So let's take for the first situation, then we will go for tan theta dash. So tan theta will be perpendicular over base. So if you look at this triangle here, okay, let me make it with another color. Here, this triangle, if you take it, in this triangle, perpendicular will be what? This r by 2, okay, because theta with the side is the base. So r by 2, and what will be your base? Okay, that will be y in this case. So r by 2y, that will be our tan theta. Equation number 3. Similarly, if I want to find tan theta dash, I will take it in the second situation. In that case, tan theta dash will be equals to r, okay, by 2, and here even the height here, because this angle is here, so this angle will be theta dash here. So r by 2, this length, and whole divided by the base. Base is y by 2 this time. So let me put here y by 2. So whole divided by y by 2. 2 and 2 will cancel out, and you left with tan theta dash, that will be equals to r by y. I hope this is clear. This is our fourth equation. Great. So we have these third and fourth equation. Let's plug in here. Okay. So tan theta upon theta dash. So tan theta is nothing but r upon 2y, and theta dash is r upon y. That will be equals to Fe upon Fe dash. Correct. Let's cancel out y with y and r with r. What we left with? We left with 1 by 2. That will be equals to Fe upon Fe dash. Fe dash is the new electrostatic force in the new configuration, right? So let's cross multiply, and we will get Fe will be equals to twice of Fe dash, okay? And let's put the value of electrostatics force, okay, Coulomb's force. What's the formula for Coulomb's force? K, Q1, Q2, both are same charge, Q square, upon what will be your here, Fe separation, R. So let's call it as K Q square by R square. And what will be your, wait, I did a small mistake here. When you cross multiply, this will be twice, okay. So 2 times K Q square by R square, that will be equals to K Q square by R dash square, correct? Now, K Q square will cancel out because the K value is not changing, and even charge value is not changing, only the positions are changing. So this implies we can write it as 2 upon R square equals to 1 upon R dash square. And if I take R dash on the other side, it will be r dash square equal to r square by 2, and r dash will be equals to root under, so this will be r by root 2, correct. So this is our correct answer. The new position for equilibrium should be r by root 2. Let's see if there is any option. Yeah, option B is correct for question number 8. I hope this is clear. Let's move to question number 9. So question 9 says, two positive ions each carrying a charge q are separated by a distance d. If F is the force of repulsion between the ions, the number of electrons missing from each ion will be, you have to find, and E be the charge of an electron. So you have to express it in terms of E. Okay. So first of all, okay, let's see here. There are two positive ions. Okay. So first of all, what we will do here? We will assume that the force, what is the force? The repulsive force between the two ions having charge q will be F equals to K, which is 1 by 4 pi epsilon naught, Q1 carrying a charge, each is carrying a charge q. So Q1 is q and Q2 is also q. So q square upon the separation, which is d square, correct? I hope this is clear. So K, Q1, Q2, that is this. And what is K? Let's write, because the final expression, if you look at the options, all are having 4 pi epsilon naught. So let me just write it in another way, 1 by 4 pi epsilon naught q square upon d square, correct? This is our Coulomb's law, correct? Now what is the charge? So charge q is nothing but Ne, where n is the number of electrons. If you remember from first chapter, quantization of, okay, charge, n is the number of electron, E is the electronic charge. Let's substitute here. So force F will become 1 by 4 pi epsilon naught. Q is nothing but Ne whole square upon d square. I hope this is clear. Now let's take everything on the other side and find the number of electrons which are missing. So n we have to figure out. So let me just make it simple and write it here as F into 4 pi epsilon naught into d square, and right hand side it is n square into E square. Okay. Now let's take E square on the left hand side. So F into 4 pi epsilon naught d square whole divided by E square, that is equals to n square, correct? Now what we have to do? Now we will find the n. Root of n will be how much? Root of n will be root under F into 4 pi epsilon naught d square upon E square. You can take out this d and e, but since in the options we don't have this d and e out of the root, so the correct answer must be option C. Let's move to question number 10 now. So question number 10 says, when air is replaced by a dielectric medium of constant K, okay, the maximum force of attraction between the two charges separated by a distance, okay, will be what? So if you replace the air with a dielectric medium of constant K, then the force of attraction between the two charges will increase or decrease, or what will happen, okay? So we have to see. So what is our force by Coulomb's law? It is 1 upon 4 pi epsilon naught Q1 Q2 by R square, right? Remember, this is our Coulomb's law, very simple. Now if you are placing a dielectric medium, which means along with epsilon naught, now we have, if air is replaced by this, so what will be your new force? New force will be F prime, which is 1 by 4 pi epsilon naught, and constant, this is K, this is different from 1 by 4 pi epsilon naught. Be very careful, this is dielectric constant, K into Q1 Q2 upon R square. Now if I divide equation 1 and equation 2, everything will cancel out and you left with F upon F dash, which will be equals to 1 upon K. So F dash will be equals to, if I take it on the right hand side and that is on the left hand side, okay. So wait, I did opposite, the K will go on the top, yeah. So this will be K. So F dash will be F upon K. So it decreases K times, okay. So this is our option A.